Welcome to today's Energy Central Power Session entitled, Can Integrating Design, Construction, and Grid Data Make a Digital Twin a Reality? A few housekeeping notes we'd like to mention. We acknowledge that given the higher demands on internet connection, where many are working and schooling from home, technical issues may be more pronounced. If for any reason we find the need to restart the event, you may join by clicking your same link again, and in such a case, we'll repopulate those links to you via email. If you cannot get adequate sound from your computer speakers, you may dial into the audio portion using the telephone number listed in the right-hand panel of your interface under the audio section. Our power sessions are intended to be interactive with questions from the audience and moderator. We invite you to submit your questions at any time using the interface on your screen. Before we jump in, we'd certainly like to extend a special thanks to Locust View for making this event possible. A little about them: Locust View provides a streamlined design, construction, closeout workflow through an integrated digital construction management platform that manages the entire construction process from planning to revenue. In the past years, they have orchestrated large-scale implementations with the leading energy utilities in the U.S., helping them digitize the construction of capital projects end-to-end. Together with their clients, they are producing industry best practices, allowing users to leverage the lessons learned from their growing network of users. Now, without further ado, I'd like to turn the floor over to our moderator, Danny Petrecca, to kick things off. Danny, over to you. The floor is yours.
Thank you, PJ. Can you hear me okay?
I can.
Very good. Well, thank you again to Energy Central for hosting this event, and special thanks to all the audience who's joining us. I see a lot of you have joined in. We've got a great topic today and we're really excited to get it started. And I think the best thing to do is to jump in and meet our panel. So what I'm going to do is just hand it over one by one. We'll hear from Randy, Geoff, Dennis, and myself for quick intros, and then we'll see an agenda for the day. So Randy, go ahead and take a minute and introduce yourself.
Thank you so much, Danny, for having us. Today, I'm really looking forward to hearing more from Dennis and Geoff as we move through this session. I came to EPRI around 3.5 years ago from Gartner, where I was an analyst on the utilities team, answering questions from utilities around the world about major systems like GIS, ADMS, and even systems like graphic work design and field work that we're talking about today. Here at EPRI, I work on grid model data management projects, and I head up a research project set titled Geospatial Informatics. And we're really focusing on helping GIS professionals understand what the future of GIS looks like and how to build the geoprocessing workflows that they need to build digital twins. Back to you.
Great. Thanks, Randy. Thanks for putting in the work to be here. Geoff, why don't you go ahead and introduce yourself as well?
Certainly. My focus has been for quite a number of years on construction and utilities, and that includes things like building information modeling, digitalization of construction, and optimizing processes at utilities. But the thing that really has garnered my attention recently is underground infrastructure, because it is just a huge opportunity. I've put a lot of material on my blog, which is called Between the Poles, and also with the opportunity to present information about the underground on events like this. Just about a week ago, we had a Canadian Underground Forum in Canada. That's the first forum we had on underground, and that's not exceptional. I think this is starting to happen all over the world, that you're seeing a lot more events dealing specifically with the underground. Today, we're going to talk about other things besides the underground, but I think one of the things that I hope you leave today's session with is a realization that the underground is an absolutely critical part of whatever you do with respect to construction and utilities.
Perfect. Thank you, Geoff. And everybody, remember what Geoff's emphasizing there. I'll show you how it all fits together in a minute. So Dennis, go ahead, take a minute.
Hi, thank you, Danny. Dennis Beck, and I look forward to speaking to you today. My background, actually, believe it or not, my family owned a construction company, so I started out at a very young age being involved with construction, but I'm a civil engineer by training, a licensed engineer. And as my career moved on, I got quite involved with design, and we as a company have been involved with integrated intelligent design solutions for the utilities industry now for quite a few years. So that's our focus, and a big focus on integration and modeling. And so, as a systems integrator, that's really where we're coming from, and those are the perspectives I'll be sharing with all of you today.
Perfect. Thank you. Thank you. And I'll back clean up here. So I'm Danny Petrecca, Vice President of Business Development here at Locustview. So, I've been in all aspects of sort of utility IT for over 20 years, whether it's been GIS, graphic work design, mobile mapping, outage management, ADMS, and now digital construction. When I started putting this talk together, I knew these four folks came to mind immediately. So I'm really excited to hear how this all comes together, and more importantly, get some interaction from you folks in the audience as well. So without further ado, we'll actually kick off into the actual content here. So here's really the lay of the land and what we're going to cover today. I'll kick off introducing the topic, which begs a little bit of introduction because it's something that's a pretty difficult problem out there. We'll then get into the various aspects of the space with each panelist. We'll hear from them. We'll keep this engaging and interactive. So you see we have 3 interactive polls set at logical breakpoints after each of the panelists, but we encourage you to make this interactive as well. Submit your questions at any point along the way, and I think it'll be a good valuable set of information for everybody. So with that, let's go ahead and get started. So this is the obligatory sort of kickoff slide that I feel like almost every webinar or marketing thing I've done in the past, I don't know, however many years has started with. Feels like everything starts with discussing digital transformation in utilities. We get together, we discuss the latest trend or driver that's going to spur change and innovation, and we let me just check the chat here real quick. And we talk about that next aha moment that's going to finally put utilities over the top this time and complete this cycle of digitization, and everybody's going to have a group hug. And this is pertinent because my career and that of the panels, you'll see, has really paralleled the evolution of all things digital at utilities for more than 20 years. So along the way, we've seen how major events have always triggered a step forward in some sort of adoption of technology. It's starting on the left side early on, many years ago, with the advent of work management, asset management, GIS evolving from maps to AM/FM and all things forward, and graphic work design. All that was driven by financial and accounting and regulation, deregulation activities. You go a little farther down the line, OMS, outage management, driven by the need for reliability and to have the right indices and safety for supporting rate cases for IOUs. You go a little further and you have the advent of AMI and ADMS, which was driven by billions of dollars in federal smart grid stimulus, and more towards the modern era where things like IoT and renewables are really driven due to the modern trend in energy efficiency, climate change, and decarbonization. But as I looked back, specifically the business I'm in today, it hit me like a ton of bricks, pardon the pun. The construction activities of utilities have consistently evaded the grip of digital transformation. They've always lacked sort of that driving event. And that's what we want to talk about today. That's the main part of this. So let's take a look at that workflow of what happens during construction. What goes on during these construction activities? Well, what you see is a typical workflow, from design on the left to construction in the middle to closeout on the right. Design starts in the engineering group who uses digital systems and expertise to plan out that next network construction activity or reconductoring or what have you. This gets sent out to the field to get built through a combination of utility crews, contract crews, and the sort. From there, that whatever's constructed in the field people gather that information and it makes it back to the office where the main systems of record are updated. You see them here, and I'm generalizing. There's GIS, there's work and asset management, ADMS and OMS. And if you're in the audience and you're from a utility, this should look familiar to you. You also know that a lot of investment has poured into the left and right sides of this equation. That's because almost every event listed on the previous slide has had major investment over time, resulting in a pretty well digitized footprint on the left side and right side of this workflow, but not construction. What is really here is a set of what I like to call a set of digital bookends, where these bookends exist with digital graphic work design on one side, a digital system of record in the IT/OT space on the right side, and a whole lot of paper in the middle. Why is this? Well, you know, you talk to utilities, you've heard all the excuses and buzzwords about aging workforce and either resistance to technology or poor technology, and we're going to look at my take on why that happens a little later. But today, it's really clear that it seems that there's just a ton of work to do, more work to do now than ever along the construction side. I'll go back a couple of weeks ago, I chaired a panel at a separate conference, and it was about aging infrastructure programs and how they've evolved in the face of modern challenges. And we were expecting to hear a lot about, you know, technology and things like that. But what we heard was, you know what, there's just so much work to be done that their biggest challenge was having the right resources to get it done and retain workers. And you add on top of that, the pressure of grid modernization, which makes for more construction, wildfire programs, storm hardening, grid hardening, all spur more construction, and then that baseline of aging infrastructure that's still got to be taken care of along the way. So maybe it's as simple as they're so busy driving the car that they just can't slow down to change the tires. But at the same time, there's an undeniable fact that the right side of this workflow, the ADMS and the DER systems, these network data hungry systems require digital twins. That's the first time I've said it. You're going to hear it a lot today. And we really want to key on what that means to us and to you. They need a digital twin. And the grid transformation that these systems promise demands a better and fully digital mobile construction workflow, yet it's still driven by paper. So maybe if we take a closer look at the problem, we'll see that it's not so easy to solve. If you look at a recent McKinsey Institute, they do this industry digitization index. It shows the relative digitization of one industry versus another. What I'm thinking is happening here, it's more of a hybrid problem. So the chart on the left shows productivity increases in certain industries over time. And you can see in the boxes that construction is at the bottom, with utilities about average or relatively average in the middle. And the chart on the right breaks it down a little more granularly and shows the different aspects of digitization across utilities and construction, whether it's their assets or their usage or their labor. And again, construction is very low, just above hunting, which is a pretty analog area, and with utilities still about average. So on paper, you could come away looking at this that utilities look to be much more digitized than you'd think. But I'd hazard a guess that the issue with construction at utilities is not really a utility digitization problem, but it's more indicative of what we see in the lack of digitization in construction itself. Now, if you look at the construction industry itself, construction and the buildings market has undergone a ton of innovation due to advent of and advances in things like BIM and digital twin concepts. And there's a company out there called Procore who is attacking this market with innovation and technology. And they are successfully increasing the productivity of the construction market. This is one of the least digital markets in the globe. So perhaps there is something utilities can learn from this. If we acknowledge that this is a construction problem, maybe we can take some cues, and if the least digitized market in the world can improve by applying technology, utilities can certainly do the same. And that's a long-winded way of coming around to what this panel discussion is all around. Can utilities digitize construction? And can they do it by integrating it with design on the left and with grid model data on the right, so that they can get digital twins like the building industry is doing? Can we stitch this workflow together with a digital thread and make it a fully digital process? And can we get rid of these virtual digital bookends? So that's the setup for the problem. What I want to do now is get to the experts and discuss why and hear their opinions. And before we do that, I want to take another look at the backdrop of this workflow, and you'll see, hopefully, why I handpicked these very special panelists. The first, Dennis, he's an expert in the design side of this equation. He's been on that left side for a long time and can well address what's happened there and what he hopes will happen in the future. I, in the middle, bring expertise in the digital construction era. Geoff, you've heard him talk about his expertise. He is clearly an expert on the global trends in all things mapping of the underground, and he is up on safety and regulations driving that. And Randy is an expert on the grid model data management side from EPRI. So together, we can cover the entire workflow, and the four of us has really had the privilege, but also the really hard work of having a front row seat to this evolution for about 20 years. Okay, so hopefully you see how this all fits together and primes the pump for an engaging discussion. So what we'll move on to now is each panelist will use some slides to cue up their main points. Then we can discuss amongst ourselves. We'll take questions as well as just do some polling along the way. And it all starts with Dennis, so I will pass it on to Dennis to hear about graphic work design role in this dilemma. Dennis?
Great. Thank you very much for the introduction, Danny. I think that sets the stage really nicely. And, you know, when we talk about design, I know the term graphic work design is used. I really like to use in, 2021 intelligent design. And, design has been around for a long time. I did it 40 years ago. I did a lot of drafting when I first graduated from engineering school. I did ink, and in about 1983, I started using my first CAD system. And I will just confess I didn't care for it too much. And that was, though, a basis, and I didn't appreciate where it could all go at the time. So to really have design that's more than just creating lines and points, there's been a number of things that have happened. And one key element of intelligent design is that it's model-based. So, rather than looking at those rudimentary elements, you have systems that really model the 3D world. They support 3D, they support intelligence and attributes. The other thing that really relates to intelligence is having something that's configurable. And when I talk about configuration, that means systems that can really adapt to changing conditions. Of course, we come from a geospatial background, so design really needs to have a geo-enablement. There is so much rich information today that is tied to location on the Earth, be it soil conditions or wind or weather or anything else that could be impacting the quality of the design, as well as long-term asset performance. We as a company also have a background as a systems integrator before we got into the design field. So integration is obviously very key to this too, having this design information tie into all the other workflows. And that has to be an important part of how you approach the design problem. And then finally, it has to be comprehensive. For anyone who's worked and has done engineering or holds an engineering license, you can look back on the case studies of things like the space shuttle. And, it was that little O-ring that caused the very, very big problem. So when we look at design, we have to be comprehensive and very thoughtful in what we do. So, now, when we look at intelligent design, though, and how it relates to digital twins, design really is the foundation. That's where the inception of a new asset that's part of anything you build starts at. But when we really look at the asset life cycle, it's just absolutely the beginning, and there's so much more information that gets added to a design or to that digital twin model. So, we're strong proponents, and the message that I really want to share with you is better designs are going to give you better results and better information to support the construction process and everything that follows thereafter. So this is core to the digital twin. And I'm like you, Danny. The word digital twin, in some respects, you will hear it and say, "Oh no, I'm hearing digital twin again." And if you look at the Gartner hype curve, and digital twins back in 2018 were at the very, very top. I haven't seen anything more recent than this, but the big question is, are they real or is it just hype? And I will just tell you that yes, they absolutely are hyped, but at the same time, they are very, very real in terms of what can be done. And we talk about the reality of digital twins. I think the big thing to understand is that we've been doing some kind of digital representations for a long time. The basic world of CAD was a very simple digital representation. Then it moved to 3D. And then it's moved over the last decade to model-based. And as we've started to do more and more advanced integration, we start to incorporate things like global identifiers that allow you to propagate this information between systems, geo-enablement, and ultimately some very robust enterprise integration. So digital twins, in some respects, have a new name, but they've been around for a long time. And if you really look at what makes a digital twin, however, work, is how it ties into the workflow. And utilities, as we know, are all about workflows to get our important roles accomplished. So with the inception of design, you ultimately create something that gets built and that gets commissioned and it ultimately gets operated. And throughout that, there are just an extensive number of business functions that are going on. There's the traceability, looking back at the historical materials that were used. There's big supply chain implications, obviously engineering and safety and quality, all the way through to the decommissioning of the asset. Throughout that digital thread is where you really have multiple systems that get involved. Design typically is done with some form of intelligent design system these days, but the assets representation will live in an asset management system. It will be supported by various analysis tools over the years. And then we get into the world of BIM and what BIM can be done in a lot of exciting applications, either mobile, analytic, 3D modeling systems. They all use the same representations of those assets. They get created fundamentally at the time of design. The next slide actually has an example of a 3D operational substation model. This is from a large investor-owned utility here in the US. I shared this. It's for a client of ours that presented last week at the Substation Design Industry Consortium. And so what they've taken is a 3D design, they've moved it into a virtual platform, and it actually is showing a very robust digital representation that now can support sensor-based integration and truly operating representations, all based on that digital design. So we're starting to see some pretty exciting things as organizations go from more robust intelligent designs to 3D operational systems. So, and then of course we have to address the concepts of BIM too, and how digital twins tie to the world of BIM. When we look at design, we think of 3D and building robust models and such, but BIM has many dimensions that have been defined. So as we go to 4D, that's really the time-based element of BIM. 5D is the estimating capabilities and the financial management. And you may not have heard of 6D and 7D, and then actually there are papers more on the academic circles written on 8D and 9D of BIM. It gets a little bit crazy as you get beyond that, but this is really where you start to model sustainability and energy analysis. And I think 7D, which is the really important element for utilities, is all about the life cycle management, optimizing your return on utility assets. So, when we look at design, though, that is really ultimately what propagates this advanced information modeling. And I'll just say for the utility audience, I actually prefer to use the term digital construction over BIM. I think that's perhaps a better moniker for it as we move forward. But Danny, hopefully that gives the audience a little bit of an introduction. I'll turn the time back to you now.
Perfect. Thank you, Dennis. So again, everything starts with that graphic work design, that intelligent design. A lot of good stuff to think about there. Let's see if there are any questions within the panel or from the audience. Do we have anything?
Yeah, Yeah, so from the audience, the first question is pretty basic, but why is there so much hype regarding the digital twin?
It's interesting. When new things come out, oftentimes they're products, and you can buy one, you can install it, you can configure it. Digital twin's a little different. It's conceptual in nature. It's really about how you model and manage information. So that means it can take on different shapes depending on who's interested in promoting the concepts of digital twins. So I think that has a little bit to do with it. It generates more and more excitement for different organizations, and so that's my initial thought on it anyway. I welcome any other panelist comments too if you have different perspectives, but definitely there's been a lot of hype.
I'll just add something as a former Gartner analyst. When I first joined the team back in 2009, and really began to understand all of what was available across the technology landscape, I had this feeling of urgency, like, wow, there's so much stuff here. And I was almost a victim of hype. It was just like, there is a lot of capabilities out there. So it was really helpful for me to understand that the hype cycle is just a very natural cycle. It happens with every technology. And we'll talk a little bit later about how new is this. Dennis mentioned it. Some of this has been around for quite a while. But the reality is that it takes time to take anything and to assimilate what it could do and then to bring it inside our organization, to socialize it, to address the privacy concerns, the security concerns, and everything else that makes it enterprise suitable. Digital twin, yeah, it's a bigger concept, a lot of angles on this thing, and we'll dig into more of that later on.
Yeah, I could add something too. I think Randy's really hit it on the head. First of all, I think you can say that there's probably about as many definitions of a digital twin as there are people on the call. So it's not like there's just one definition out there and we're all striving towards that. The other thing is that the concept of a digital twin, as opposed to maybe different digital twins for different aspects of your business, is an interesting one. I remember a Gartner study quite a few years ago where they went to one large utility on the West Coast and they looked at how many different groups were maintaining information on poles, like joint use, what's on it, cross arms, this kind of stuff. And this Gartner study found that there were 9 different groups maintaining independent data on poles for different purposes. In one case it might have been joint use, another purpose, another case it might have been they were looking at woodpecker holes or something like that. But so the concept of having a unique digital twin for utility is relatively new and is probably a lot more complicated to arrive at if you start looking at how many different versions of different data that you have within each utility.
Geoff, I don't disagree with you at all, but listen, look to the construction industry, look to building information. You have concrete, steel, you have the trades, you have electric, you have water, you have telecom within a building. Everybody's got their own little silo of data for that work that they're going to do. So bringing it to the construction side, is that a valid concept to say, well, hey, BIM in construction for huge skyscrapers or residential is working? Will that help sort of glue things together for utilities in construction?
I think it's one of those things that just has to be worked through one at a time, not trying to jump to solutions, but there are so many different representations. You're right. And if we're looking for it to get better, it may not. As we start getting more and more advanced systems, I think the important thing to consider is how we manage those different transitions and how we model it so it can be utilized throughout all these different systems. As we start getting better and better at what we do, you will find that there will be more specialized applications. That's just progress in some regards. You can open up your cell phone and I just noticed the other day that I think I have over 60 apps now, and I think most people do. So it's not going away in terms of specialty functions. It's how we manage the information. And that's, I think, really at the essence of what proper digital twin definition and management really is all about.
And I think another concept that I think is germane to this as well is the perspective of the persona who is creating or utilizing a digital twin. Dennis, from your end, a person puts together a beautiful 3D digital design in CAD, and to them, that is the digital twin of that design. But what a person needs to spin up a convergent state estimation model in an ADMS on the extreme right of OT, they can look at that beautiful 3D drawing, but to them, it's not a digital twin. They need 20 more pieces of data about that transformer or that capacitor bank for it to converge. So they need their version of the digital twin. And I think through this workflow, I want you guys to remember, I think there's a persona problem that goes through the entire thing that really makes it even more difficult, not just within a utility, but then you bring in contractors to the mix as well. And it's even
And, you know, Danny, more isn't always better. And when we start talking about adding all those details, you know, there's also the person out in the field who needs to find the closest valve at 2 a.m. in the morning when it's dark and it's raining, and they need to do that safely and quickly. And they don't need all that information. So it's not just getting all those details. Sometimes it's removing the pertinent details without completely dumbing things down, obviously, so that you can do safe operations. I think one of the biggest problems we have in information technology is making things too complex, trying to do too much for the, you know, for everybody, rather than, as you mentioned, selecting the right persona to do the right job.
Yep.
Yeah, and the other aspect of the persona is who's responsible for what. One of the themes that we're going to be talking about today is the issue of data quality. How do we make sure that data is up to date, that it's complete, and that it's accurate? This is a huge problem for underground stuff, but it's also a problem for other parts of this construction process that leads to utilities. And part of the problem is, as you said, Danny, is that we have different people responsible for different things. And if you look at a construction workflow, one of the really important things is that when you're talking about underground, it starts off with a call before you dig. But call before you dig, in a call before you dig process, there's no liabilities. People come out and they spray the ground, but there's nobody who has to stamp something or sign something. And we'll see that what's happening now in this area is that there is now more responsibility being assigned to people, basically so that if something goes wrong, you can sue somebody.
Yep. Yeah, and that's a great point. And you know, and I think one of the most underserved personas in this workflow, maybe I'm a little biased of this, is the construction crew persona, right? Like we talk about, we need more data, we need more stuff to be collected so we can share more data. Are we going to have construction crews collect 50 pieces of data about a piece of pipe or a piece of conductor that goes in the ground? We'll get to that in a minute, but this is really good food for thought. So, hey, Matt, do we have any other questions there, or should we head over to the poll?
We do have a lot of good questions coming in. I'll pick out one more, and for anybody whose questions don't get answered live, know that we will follow up on Energy Central afterwards. But this person asked, you know, one of the challenges with adoption of digital construction is change management with field crews. How do you improve the willingness of field crews to leverage the digital technology?
It's really good, and I'm going to spend some time on that in my section, but I think we said the word persona a lot in this last discussion. I think it really comes down to that. You know, the idea of aging workforce and people in the field resisting technology, that's starting to turn over. I mean, we're seeing everybody's got many of these in their pocket, especially construction folks out there. They know how to use technology. I think they just need to have an app or a solution that matches their persona, matches their workflow, more importantly, and doesn't make them feel like they have to be a design engineer or a GIS professional, right? It's got to give them just the right stuff at the right time to collect data. And then I'm going to talk a little later about sensors and how even with the most beautiful, friendly app out there, you need help from sensors to capture more and more information.
I would agree with that, Danny. I just add one other thing, is that when you give an app to a construction team member, it's got to be something that's not going to add to his workflow.
Exactly. Yep. Great. So we'll definitely hear some more questions later. Let's move on to interactive poll number 1. You'll see this poll on your screen. This is, we're trying to tie this idea of design to construction here. So it's a question, it's not often asked, but see how strongly you agree with this statement. My current design process makes construction and the closeout process easier. You strongly agree? Do you agree? You're neutral? Disagree or strongly agree? Disagree, sorry. So we'll leave this open for a minute and then we'll talk about the answers here. So think about taking what Dennis talked about, that intelligent design. Does that serve its purpose just as a design, or does it actually make construction better and easier? Does it make your closeout process easier, that right side of the workflow? All right, so we've got some polling results here. I can't see them very well. Let me see if I can make this a little bigger here. All right, there we go. So, we've got about a third split right around that neutral. Nobody really, well, nobody strongly agrees, and that's not really surprising. There's a couple folks who strongly disagree. So, Dennis, what do you make of this? Is this unexpected to you?
This actually, I think, hits pretty well. I am, in some respects, would have expected maybe a little more strongly disagree.
Yeah, me too.
But I think there's opportunity, and nobody's strongly agreeing, and that's really where the opportunity lies. How can we do things much better than we're doing them today?
Yeah, and I've actually split this question into 2 in the past and gotten some different results. I've said, does it make construction better? And there's usually a lot of agreement there, but I've then split up and say, does it make closeout easier? It typically tends to skew it in the negative, saying, well, no, we can get construction done safely and quickly, but there's still 2 weeks of paperwork before I can close out the job.
Right, very common, isn't it? There's that digital cliff once you start the construction process. You can create the best design, then it gets printed and goes into a folder, and it's all paper again.
Okay, well, let's move on to the next section, which is my section here. And this is going to try to tie this idea of construction to digital design. So what is needed during construction to take that digital design and create a digital twin? Well, first, let's take a closer look at why paper is so ubiquitous today. I think everybody here and in the audience, you'll agree that no matter how many utilities you talk to, it's really uncanny. They all use paper in the field. It's not even close. And by the way, if you're out there and you say I'm using something digital, a PDF doesn't count. That's just digital paper. It's not quite the same thing as a digital process. So, but we know the issues this causes. 30 to 60 to 90-day mapping backlogs. And when you really talk to the folks managing this, they seem to be okay with it. I mean, I don't want to be too candid, but it's very clear that it's a hard problem and they don't really know how to solve it, and it doesn't feel like they're being pushed to solve it really well. So let's take a closer look at that. So to me, the answer is really complicated as to why they use so much paper. The first is just the resistance to change. The construction today is managed using a variety of manual paper-based processes and partial solutions. The construction workforce might be resistant to adopting new tech, and they would rather use paper, even if it adds delays and causes errors. And it gets even more complicated when you consider the number of contractors doing the work for utilities. Utilities are also using a lot of partial solutions. So, well-established enterprise systems such as work and asset management and GIS are extremely valuable and have become mission critical, but they don't provide the full mobile solution catered to a construction crew, the thing that they need for long cycle construction projects. And A lot of utilities are just getting by with something that's really just good enough, and you can't really fault them for that. Now, if you look at the problem a little more closely, it's really difficult, and I want to explain this to you. It's difficult because of all the numerous different personas involved. So remember the discussion we just had a second ago. Think about this. This workflow is tasked with taking a highly technical engineering output from an engineer, translating it into instructions that a construction crew can use to safely and accurately build a job, then translate it back to data that a GIS tech or an ADMS operator can use to update their data. This is no small task. And it's not just about the distinct personas. They all work in different teams in a utility. They use different systems. They speak different languages, and they have different goals and accountability. Really, really difficult. Finally, there also seems to be a lack of ownership, and if you don't believe me, go to someone, actually go to 5 different people in your utility and ask them, hey, who owns as-builting in our utility? Is it GIS? Is it engineering? Is it construction? So to get past this, I think utilities really need a different approach, and they need a digital approach that is streamlined and paperless. First of all, they need that digital payload from the left. They need that digital job packet, not a paper job packet, but a digital job packet that enables them to record their construction data digitally and also close out, digitally automate the closeout on the right side. And they need tools, like I said before, that match the requirements of their persona and the workflow of actual construction. But how can crews be expected to collect all this high fidelity data and still get their jobs done? You don't want them out there backfilling at midnight because they had to capture 16 reams of paper about a transformer they just installed. I propose that they need to be aided by new technology, just like that the construction folks that Procore is serving. They need to be aided by new technology if there is any hope at them capturing more data using field crews. You better be using sensors to rapidly collect mass amounts of data along the way. Luckily though, technology is coming up and hopefully can get us off that hype curve. There are advances in mobile software and cloud. That's really the base, that innovation that has set things in motion. Then you have the ubiquity and the cost effectiveness of high accuracy GPS with RTK to give you that high accuracy surveying result. And now more than ever, there's things like LiDAR. I mean, probably have LiDAR on your phone today, right? It's probably not the resolution you need, but LiDAR and all the realities, the AR, the VR, the XR, augmented virtual reality that can make this real. So the concept of field crews digitally capturing construction data can be the best practice instead of just a fantasy. And then in this way, construction crews can use a solution in the field with all these sensors to create a digital twin in the field during construction. But it's all tied back to that design where it starts. So you have to have that integration. Now, if utilities do this and a design is digitally integrated, crews can then go beyond just simply creating an as-built report for GIS. Anybody can do that on a piece of paper today. Maybe that's why they're doing it. But utilities can produce as-built records that construction can trust and locates can trust, that can also power the grid model. And here's another view of sort of this idea of a digital twin. Here, when we talk about digital construction, digital twin within digital construction has to take into account all the personas here. It's similar to the concepts of BIM, where multiple stakeholders in the workflow of building a building can all simultaneously contribute, collaborate on, update, and track the progress of construction as it's happening. Now, utilities can tie this all together and in a way that's creating a true digital twin by arming each persona to capture their data along the way. So it's not just about mapping or as-built data, it's about asset data, it's about inspections, material traceability, verification, reconciliation, validating against the design, detecting and creating and managing design changes. Utilities can really realize this idea of design making construction better and making closeout better. So this is like the big moonshot here. Can we do all of this with tying it together with a digital thread, creating a digital job packet, doing digital construction and automating this creation of a digital twin. I think you have to do it with advanced technologies. But when we do this, I think it definitely has the value of making construction better, making all design and engineering work digital. It has the ability to make construction more efficient by tracking and managing changes between design and construction. And in turn, it completes the full circle because the next design and the grid model data will be better. It all comes full circle since that digital twin forms the basis for that next design. So that's that middle piece there of digital construction. So with that, I'll open it up. Matt, I'll check back with you to see if we have any questions there, or open up to the panel to discuss what was just talked about.
Yeah, the Q&A continues to be pretty active. I'll start with this one though. How is digital construction different than mobile mapping, GIS, as-builting, or redlining?
It's a good question, and it's a difficult question because all those things you mentioned all have value within utilities and they're all established. But digital construction to us is about not just creating a point or a line on the map that represents where an asset is located. It's about everything that goes into how that asset was designed, how it was located there, the serial number, and all the way up through the supply chain, where it came from, almost a blockchain of that piece of equipment. And then everything that goes along with closing out that work order. It could be the hours used. It could be the O&M manual that gets created on the back end for the 5, 6, and 7D of the BIM part of it. So it's much more than just recording a map. It's about the work management aspects, the asset management aspects, the O&M aspects into the future, and documenting the full lineage of things that are done in the field, by who, when, which crew. The contractor side of it makes it much more complex as well. So it's much more broad than just drawing lines on a map.
Danny, can I add to that one?
Absolutely.
You know, I think the other really big thing, and I think one of the biggest challenges in construction, is the communication chain. So when you have this digital, you really start changing communication. It's not unlike, you know, going from sticking something in the mailbox to sending an email. So the ability to communicate construction changes, design issues, all those kinds of things to the appropriate stakeholders, the people involved with finance, engineering, safety, those things can happen at just a completely different speed. And that's when we really start to change things from in the field. You know, so there's, you know, all those systems you described, very important for documenting, managing information and such. But once you start to break down the communications barriers, is when you start to really realize a lot of results.
Yep.
You know, Danny, could I add something here? I think Dennis has really hit it on the head, and your talk hit it on the head as well. You know, when you talked about different personas, because one of the problems when you look at a full life cycle workflow, which means from planning, design, building things, commissioning, O&M, is that if you look at design, if you look at a fragmented process where you have one group who's an engineering group who do the design, they throw something over the fence to the contractors. The contractors take this thing and they're supposed to go out and build it. When they're done, they throw it over. When they're done, they throw it over the fence to the owner, and the owner hands it off to the. You know, that process is and that is a typical construction process. There are companies who do full life cycle construction. They're sometimes referred to as triple P. There's other ways of referring to it, but it means basically build, design, and operate or maintain. And when you look at the process involved in those kinds of construction projects, as opposed to the fragmented construction project, you can often find that the design guys are, you know, saying, great, I'm going to design this wonderful thing. They're not really worried too much about constructability. They're certainly not worried about O&M. Right? Yeah. Contractors take this thing and say, well, okay, we've got whatever we got from those guys. We'll try to build what they gave us. And they're not too worried about O&M either. And so I think this, starting to look at this as a concerted process where you're really at the design phase, you really want to design something that is easy to O&M, to maintain and operate. Gives you a bit of a different perspective, and that's what I was just getting from your talks here. That you're looking really more at a complete workflow for a project, including O&M.
Yep. Yeah, it's almost like as if you're turning over, like the design has to start with the end in mind, the end of how to operate and maintain this from cradle to grave. You almost envision it as, so it, again, I keep bringing up BIM and building constructions, but if you think about it, somebody does a lot, designs and builds that, then they have to hand over what is ultimately an owner's manual to the asset owner to say, here's where I put every nut, bolt, screw, and girder, but also here's how you maintain that thing, and here's how it was different from what I designed it. Here's how in 10 years you're going to have to replace this thing because that's how I designed it. I think that's missing. The other part I'll put out there too is the idea that designers throw it over the wall, construction has to get it done quick and move on to the next thing. Bring back that idea I talked about where at the aging infrastructure and the lack of resources, utilities are finding it hard to keep their own construction resources because they're going from contractor to contractor where they can get better contracts or more work, so that if you're delaying a job for them, if you're giving them more to do, they're going to just ditch and go to the next contractor and make it that much more difficult to get their job done just because there's so much work to be done out there.
Yeah, and another aspect of that problem is the fact that there is still a certain amount of a culture out there that says, just get it in the ground, don't worry about the record.
Yes.
Yep. Well, but at the same time, that aging infrastructure panel that I discussed, they said the other big thing that's coming up is, or that they're hearing is the change from liability to safety. They said it's no longer okay to not know. They said we're getting this pressure that we can't just throw it in the ground anymore. We have to document it because it's not just get it in and get it pressurized or get it energized quickly so I can start making revenue on it. It's document it so the next time there's an issue or a lightning strike or an arc, I can document that I built it correctly and I know exactly where it is and hold us not liable.
And I think you've really, often in a discussion like this, the elephant in the room is liabilities.
Yep.
If you know that you put it in the ground and you provide inaccurate as-built, and as a result, somebody gets injured or a project is delayed for 3 months or whatever, and you're liable for it, I think that's going to motivate people to put a little bit more effort into recording the location of things.
So Matt, any other questions before maybe we move on to the second poll?
Sure. One more quick one. Somebody was asking, would it be possible to comment on applying 3D print technology along with the digital twin technology to real life utility projects?
3D printing. I'm not sure. Dennis, any of you other folks have any comments on how that might be incorporated?
The models that we create when you do an intelligent design support all of that. And so the capabilities are there. We're not seeing organizations use it. Part of what we have been trying to do as we implement models is simplify a lot more of the material management aspects. So organizations will historically have developed, in the utility industry, compatible units, and they may have millions of them, and that becomes a big management challenge. And so our focus has been to try to minimize the amount of components they need to deal with. Drive more standardization through better design, and that then flows down into construction and everything else. So, we haven't been seeing that, and I think that's in part due to the approach we've been taking. Obviously, when you look at aging assets that are very old things that aren't manufactured anymore, that it can certainly change that profile I just described.
Great. All right, so let's go ahead and move on to the next poll here. See that popping up here, and it should relate back to the piece I just did. So this is, I know, something people typically record, and I'd love to hear the answer to this. What is the typical duration of your average as-built mapping backlog. And the definition of that is from when construction is done, when do you receive that stuff back, and when is it updated in your system of record? Mainly talking about GIS here as that main system of record. Less than a week, 1 week to 1 month, 1 to 3 months, 3 to 6, more than 6. Always love to see this answer. I had one utility tell me it was less than a week, but when I pried a little more, they said, oh no, once the GIS team gets it, it takes a week. It takes 90 days though to get it from the field. So I said, well, that's your mapping backlog is 97 days, not 1 week. All right, let's see what we got here. Okay, there are a few of you folks that are about more than 6 months. That's not surprising. 3 to 6 months. The majority of you, 3 to 6 months. That's it's unfortunate, but that's the reality we have. 1 to 3 months. That's not as bad, but 31%. 1 week to 1 month. 15% of you, and nobody is getting it in within a week. It's funny because I talk to utilities and they tell me it's a week. So I think when you get the right people in the discussion, you have to ask why 5 times to really get down to it. All right, let's go back to the slides here. And with this, I'm going to pass it off to Geoff to talk about what happens when as-built are poorly managed. Go ahead, Geoff.
Okay, great. Thanks a million, Dan. This is a very interesting discussion. I think we've really touched on some really key points. So I think most people are probably familiar with the problem of the underground. I won't go into the fact that this is a risk to the public. It's a risk to construction workers. There's liabilities involved in this thing. The cost to the U.S. economy is on the order of tens of billions of dollars every year. The CGA, which is the Common Ground Alliance, which collects information about the underground, says it's around $33 billion a year, the cost to the U.S. economy. So it's a real drag on the economy, and it's a real drag on construction in particular. And if you've been in any construction projects, or if you had anything to do with federal highway projects in the United States, you know that underground utilities are the single biggest cause of delays of highway construction in the U.S. So this has really significant implications economically, health-wise, and from the point of view of actually getting things done. One of the statistics you may not have heard of, and this is just an estimate, is that the U.S. spends something like $10 billion a year finding things underground. This would be in response to one call. This would be utilities coming out, or locators coming out on behalf of utilities in response to one call to find out where things are. It includes what's called the locate industry. It includes telecoms. It includes utilities, and it also includes construction contractors and sometimes road authorities. Construction contractors, after somebody comes out and paints the ground, they will often do their own investigation to verify that the utilities are where they are. The saddest thing about this is that we're spending $10 billion a year finding things underground, but this information is rarely recorded and rarely shared. The only thing that's required of the utilities or locators when they come out in response to one call is to paint the ground. In many jurisdictions, no paper has to exchange hands. There's no digital exchange of whatever. And if you're going to dig in the same place a year from now or 2 years from now, exactly the same thing will happen. They will come out with their EM devices and their GPR, and they will mark the ground. So basically what we're doing is we're capturing information and throwing it away. So that is, I think, one of the things that is really critical. The really good news is that there has, in the last 2 to 3 years, there have been some really interesting innovations in mapped underground infrastructure. And I put them into several different categories. One is legislation and regulation. I'll come back to that. Another one is reality capture. This is traditional reality capture. This is using LiDAR, often with a GPS with RTK, so you have high accuracy GPS available. There's new technologies for locating things underground, and this area is really just going gangbusters right now. The amount of new companies, mostly startups, that are coming up with new technology for finding things underground is remarkable. It's actually kind of paradoxical that we can put a satellite up 600 kilometers and it can, and it can detect things at centimeter level, or at least 30 centimeters anyway. But 6 feet under, we don't know where things are. Another area that I'll just chat about very briefly is cloud mobile. This is basically using cloud technology plus a handheld computer, often with RTK for accurate positioning, being able to capture construction, new stuff going in the ground, utilities that have been exposed during construction in real time. Right? This is not 3 days later or 3 months later, as is typical with paper as-built. This means in real time. I capture it, I upload it to the cloud, and it's shareable within minutes. I mean, this is a really important evolution of technology. Standards, if you're familiar with ASCE standards, 38, for example, those are evolving, and in most countries, these standards are evolving to reflect the fact that the new technologies we have out there make it a lot easier to get accurate locations for underground infrastructure. And just to put this in context, this means that we are now, I think, on the brink of being able to put the data together that we require as a foundation for a digital twin. I'm not talking about building a digital twin, not simulations and all sorts of other wonderful things you can do with digital twins, but just having the foundation data, knowing where things are accurately, and having business processes that allow that data to be kept up to date for the lifetime of the infrastructure. So let me just go back briefly and just touch on legislation and regulation first of all. First of all, I think this is probably one of the most important areas that's happening, and it's happening in a number of jurisdictions in the world. This is not just one that decided they were going to do something and everybody else is watching them. This is happening in a number of jurisdictions in the world. In North America, I would say the leading light here, or the real lighthouse model of which people are keeping in their eye, is Colorado. And the remarkable thing that in Colorado is that this was basically created by the Colorado legislature and enforced through regulation and through a specific body that was put in place to enforce these regulations. And there's two fundamental regulations. One is that when you submit as-built at the end of a construction project, they have to be accurate. And specifically, they have to be signed by stamped or signed by a PLS or PE. This is getting into liabilities and responsibilities. If you don't have things that are stamped or signed, nobody's responsible, and you often suffer the consequence as far as data quality. So that's the first big thing. First, in Colorado now, when you do any work in the public right-of-way for the Colorado, involving the Colorado DOT, you have to submit within 45 days. You have to submit accurate as-built. That means survey grade as-built. The other thing in Colorado that's really innovative and I think is really going to change the industry is that before any public highway project, for example, you have to do what's called a subsurface utility engineering survey, which means that you have to find everything underground in the area where you're going to be building your highway to ASCE level B or better. Okay, so that means you use whatever remote sensing techniques you can, and there's, like I said before, there are a lot of new technologies out there to help you do this, detecting things using satellite imagery to look for where things were put in the ground or whatever. So Colorado is in North America is really an important market. Montana has also legislation that says you have to have accurate as-built, again, signed by a PLS or PE. And if you look around the world, in the UK, there's a project called the National Underground Asset Registry. Ontario now has, in the last year, has three new pieces of legislation that put severe penalties on problems of accuracy and delay relating to underground infrastructure. And I could go on for France, Singapore, and so on. So this, I think what I would like to convey is that this is a big thing now. Underground used to be out of sight, out of mind. We don't worry about it. We just do it the way we've always done it. This is changing. And the fact that in Colorado, I think this legislation was passed in 2018, 2019. This is very recent, but it's having a really big impact, not only in Colorado, but on other jurisdictions around the world. And so I think that one of the, if you recognize that underground infrastructure is a key part of a digital twin, and right now that is really in not good shape. In other words, if you look at the quality of data in every state in the union, and if you look at it, the same in every province in Canada, the quality of that data is substandard. Nobody would use it for digital, with some exceptions. I think that what we're seeing right now is a combination of regulation, legislation, and technology that is going to provide a firm foundation for the digital twin of the underground, which could be combined with the much better data that we have above ground, as Dennis has outlined, to create a real digital twin of our utility and telecom infrastructure.
That's excellent, Geoff. One thing I talked about in the beginning, before we get to questions, is all these spurs in technology in the past were driven by some outside force or some seminal moment. It feels like we're kind of driving towards that in construction, to where, not that it would go as extreme as sort of the PHMSA mega rule did for plastic gas assets, but you're starting to see this snowball build of regulation and compliance drivers out there. And I agree with you. It's going to all come down to liability, because utilities they can't stop the car to change the tires when they're getting down the road just fine, until a cop stops them and says, pull over, you gotta change tires on your car. Exactly. Terrible analogy. Yep. Terrible analogy, but it's going to take some outside influence. And typically when we've seen disruptive innovation in the past, there has to be that three-legged monster, and that third leg always has to be some sort of government stimulus or regulatory requirement. That's what I think it might come down to. Matt, do we have any questions from the audience here? We're running short on time, so I want to go a little quick though.
Yeah, I'll pick out just one then. So Geoff, do you think there will be a mega rule equivalent event to push for digital construction for electric utilities?
I think there's several reasons why that probably won't happen. But I won't go into what's actually happening. Everybody knows about FERC and the fact that there's state regulators and there's federal regulators, and FERC is not really an all-powerful organization, as for example the Bundesnetz is in Germany, where they can regulate across states. Yeah, I think the rule in the United States is if you're going to put a transmission line in, don't cross a state line. But I think the other thing I would say on this, that if you look at what's happening in Colorado, when you look at what's happening in Montana, it's the DOT, it's the state's responsibility for the public right of way, which is driving these regulations. And I think that I would expect that, I know that other states are looking at this, DOTs in other states are looking at this, MOTs in Canada are looking at this. And I think that what we're really going to see is that it's probably going to be things like transit, transportation, that sector, which is responsible for a public right of way, which is probably going to be the main force between introducing regulation and legislation relating to underground infrastructure.
Excellent. So let's move on to poll number 3 here, again, directly related and tied to this. Really loading up some good questions here. So how strongly do you agree with this as a utility? I trust my as-built enough to safely support field locates and also create an accurate grid model. And kind of 2 questions in one, but it's relating to passing this off to Randy in a minute, who's going to really give us some great information on grid model management and how this is that last part of the workflow. Do you strongly agree, neutral, disagree, or strongly disagree? Leave that up for another minute or so. All right, let's see the results here. So what we've got here is, it's skewed towards the neutral to disagree side. 75, 80% are either neutral or disagree or strongly disagree. Only about 16% of you agree, and there's about 100 of you on the line right now. So 16 of you feel pretty good about your as-built. So the evidence keeps mounting here, folks, that this is a big problem. We don't have the solution for you. We're just a bunch of guys just talking on a panel, but we know the solution is out there for you. All right, let's move on to the next piece here. We'll bring it home with Randy. Randy, I will run through the slides for you. Let's talk to Randy about EPRI's role in this and the idea of model or grid model management. Randy?
Thank you, Danny. Let's start just by talking about a definition. What is a digital twin? Like IoT, if you've heard a definition with the word thing in it, you're like, forget it. You're skeptical, like many of us engineers. So I left out the thing part. But in reality, it is nothing much more than a digital representation of the thing in the real world. There are elements here, and I've just listed this off the top of my head. I would encourage this as an exercise for you. I've listed some resources at the bottom that will be available. You can click through when you get the PDF and read some of this. And think about it yourself and develop your own definition for what you believe a digital twin is. Most of this is very familiar to us. We've talked about the data. We've talked about modeling. We've talked, many of you are personally involved in simulations. If you're working in a control center, working with the ADMS, trying to get the benefit out of the ADMS or the DERM system that you've deployed. A couple of aspects I might mention, though, is that this thing of connections. A lot of people don't realize, well, digital twin not only should consume data streams, real-time data streams, like from a historian that we're very used to in our sector, but also to be unique in the sense that the twin corresponds to a unique physical thing. There's an atomicity aspect to this where you can combine and recombine twins to create systems and representations. A lot of people don't understand those two aspects as well when we think about digital twins. So really, it's not so much what your definition is, but more how you think about it. Let's go to the next slide, and I want to give you a backdrop. We, in reality, and trust me on this, I'm not making this up, there are corporations around the world investing literally billions of dollars right now to build out what is called spatial computing. More generally, maybe called the spatial web. This will be built on top of the web as we know it today. Yes, we've got the real world at the bottom of the diagram there that I show in the upper right. And then we have a digital representation, that reality capture layer. Many of us are familiar with the reality capture technologies. I'm showing a LiDAR scan of a substation and a distribution line here. Many of us have these already. We've got these digital resources. And then we have the experience. This is what it's like to actually not just watch something on a flat pane of glass, but to be inside of something, to walk through that substation and to look at the clearance that I need to sort out before I can submit my design for approval. This is a result of a convergence. On this diagram on the left, I've just listed some of the technology trends that are impacting our field workers today. Over the next 5 years, there's going to be a really dramatic transformation of what happens in the field. We know it's going to happen. How do we know that? Just walk through all of these. The availability of 5G, massive spatial data marts available, being able to get data from almost anywhere through the cloud, and even edge computing. One of the things we're looking at very closely is how to maintain the integrity and the uniqueness of the network model from the design all the way along this digital thread, all the way out to perhaps a DERM system that's operating on the edge of the grid, interacting with some third-party providers, and stabilizing the effects of high, for example, EV penetration or high solar PV penetration on rooftops. This is a challenging thing. And when we say grid model data management, that's what we're talking about. On the next slide, I've got a little bit more information here about what can be done. How real is this? This is one example of a commercial application that came on the market not too long ago. Again, by sort of a boutique shop who's been doing AR and VR work for a couple of decades. And when they met a substation engineer and started talking, they realized they could actually do this. They could start with CAD files, and they could build basically a training simulator for substation operators who have the responsibility to go in, perform all the lockouts, the safety lockouts, double check the CAD diagrams, connect with the dispatcher and make sure that all of the safety precautions have been taken. This includes, by the way, just making sure that they don't get close to something that could produce a shock from an induced voltage. So this is a fully responsive simulator where we're running algorithms in the background, and those algorithms produce changes in the environment. You see the bus bars change. You can see the EMF fields above you and see those change as you perform some switching in the substation. So it's taking the physical, moving it into this mirror world where it mirrors the actual physical reality, but going even further, taking the individual into that environment and letting them experience what that is like. Well, if you've been in a substation, most of us have, you know that when you're doing a voltage check on a high voltage bus, or if you're operating a high voltage breaker at 345 kV, the hairs on the back of your neck are standing up. Am I right? There's a physiological experience knowing that something could go wrong. And it's that experience really that brings people into a learning environment where the learning sticks. One of the safety training executives told me on a call, I would rather have one of my operators fail 10 times in this environment in order to avoid just one small mistake when I send him into that substation. So that kind of experience is available now. Another example is on the next slide. Can we scale this even further? How scalable could digital twins be, or this whole concept of combining and recombining digital twins of infrastructure? There's a lot of activity happening in the architecture, engineering, and construction market right now. For example, if you go online, you can click through some of these URLs later. Some really fascinating work going on in New Zealand and Australia. I'm showing here in the picture a virtual clone of Adelaide. This comes from helicopter-based photogrammetry. No big surprise there. What's different about this is the cars you see are not real cars. This has been rendered using Unreal, a gaming engine, and they've added in Twinmotion, which allows you to put human figures, cars, trains, transportation systems in place, give them a route, and turn it on and let it run. So you're actually simulating the dynamics of an entire city and then looking at security scenarios. What would happen in a certain situation? What would happen in a typhoon? What would happen if perhaps we put solar on top of all the available rooftops? What would that look like, and how would it impact the ray tracing capabilities, the surface surfacing capabilities that's available today off the shelf in these gaming engines are making really compelling and real experiences. So when we think about urban planning and the utilities' involvement in that, this is a really key development. On the next slide, I want to just walk through 4 very simple things, and I'm going to use a baseball diamond to kind of help us think about how to get to first base and then how to go beyond that. You might be saying to yourself, this is a big concept, and it is, trust me. I wrote a white paper last fall on digital twin, and I spoke with approximately a dozen people outside the industry to try to wrap my head around how all of this fits together. First of all, enable the virtualizers. These are the people who are experienced already. They've scanned their project office with their smartphone, perhaps. Maybe they scan their latest line extension project they have out in the field, and they're sending that back to the office. Maybe they've scanned an entire substation, or they're supporting the idea that we need to scan every substation to support our brownfield improvements. You know, putting that new bay in, that new bulk power transformer. Support these individuals. They are the ones who will build a wide collection of imagery, whether it's truck-mounted cameras, whether it's drone-mounted imagery or other digital resources that can be collected during inspections. All of this really becomes part of the repertoire that you can start with. Kinds of things Geoff talked about with, you know, digital representations of the underground resources are becoming available now. We can pull those in and make those geospatially located and incorporate those in the digital twin. Well, do everything you can. Lay some bunts, hit a grounder, get to first base. What comes next? Well, it's really about building a model. We've talked about that already. With intelligent design, you can make this happen. If you take these LiDAR sources, imagery sources, and the grid model data, if you can extract that from the construction process, well, that's a good start. But you really have to model it in the way that we've talked about during this webcast, so that the data can be properly interpreted as you round the corner and head for third base. What is third base? Third base is simulation. One of the first publications here at EPRI about digital twin did not come from a guy like me in power delivery. It came from someone over in nuclear. And it was really about simulation. If you can simulate the actual behavior of a new advanced nuclear plant with all of the thousands of components, you've solved the problem before you get to the design, right? So we can model and simulate, but it takes a lot of good thinkers to make it work well. Many of us have been involved in digital state estimator rollouts with EMS systems over the years. Now we have dispatch operator training simulators with the ADMS system. In certain regulatory markets, we're looking at making DER data available to a wide variety of parties so they can run their own simulations. And how are we going to hand all this data off? Well, we start by defining the data requirements, providing these data connections, and eventually the digital twin itself will sort of be the best, or at least most appropriate, source of digital truth about the physical reality. Finally, I think this is an important step that's easy for us to miss, particularly we engineers who are quite fascinated with the first 3 steps. Many of us were very close to what happened in the southern U.S. During the polar vortex this year. We stand with those who did their best to pull through that unexpected climatic event. And if we were to go back in time and replay that, we might ask ourselves, could we have avoided this? Well, we know how to simulate the grid. That part's working. what we didn't do well was to simulate effectively using this approach the regulatory impacts or impacts of non-regulatory action on the plants who didn't weatherize their systems adequately. Maybe we didn't really model resource adequacy well enough, given the diversity of generation sources in that environment. Maybe we didn't model the climate effectively enough. There's really nothing stopping us at this point from looking at this in a fresh way. So I really want you to think about, what is the story that I am in? How can I start small and focus on one story? Is it reliability? Is it climatic impacts? Is it fire danger for EV owners wondering if they can get away from a fire in a bad situation? And we've got that data, and we can warn them to get their vehicles charged up. These are things we can do if we take the diversity of these stories, we pull in a lot of diverse team members, and we think broadly about the changing regulatory and climatic conditions that we're in and the challenges that are in front of us. Decarbonization is another one. Think broadly about the story. What experience will help the executives in your organization understand the impacts of the design decisions that we're making today and how we move this data into a digital twin? I'll stop there, Danny, and hand it back to you.
Excellent. Perfect timing, Randy. Appreciate it. Really good stuff. So we got about 5 minutes left, so I want to see if we have any questions, and then we'll need to wrap it up. Matt, do we have anything coming in on the Q&A panel?
Yes, we do. For Randy, somebody asked, aren't digital twins really just another word for what we are probably already doing somewhere? What's new here?
We've all been managing grid model data for most of our careers in one way or another. And that just speaks to my area of grid model data. So in some ways, yes, we've been doing this for many years. I watched a documentary last week about the impacts of our cities shutting down. It's a really fascinating video by a photographer in North India who, when he walked up onto his roof, discovered he could see the Himalayan mountain range. It had been there for 40 years, and he'd never seen it before. That's kind of how I feel about this shift to spatial computing, about the capabilities that digital twin can provide. It's kind of like I've never really seen this before, but it's been there all along. I think my immediate response would be just to ask the question, how much time have you spent in one of these? Get a headset for a few $100, take your grandkid, go stand on a plank on the 20th story, feel the physiological effects, and then go back and look at your business.
That's great. Thanks. So, Matt, we do have a couple more minutes. Any other questions out there? Anything the panelists want to? I have a question I'd like to ask the panel, but I'd like to give it up to the audience first.
Sure, I can pick out another audience question before tossing it back to you, Danny. One attendee wanted to know, what are the key selling points to a business leader on the benefits of the digital twin concept?
Randy, I think your piece set that up pretty well. You want to take the first stab at it?
Yeah, I wrote a white paper on this last year, and I would just summarize perhaps by saying, if we continue to do things the same way we've always done them, we're going to get the same results. And we're doing a lot of the same things the same way. We're thinking about GIS, for example, as the mapping system. It's all changing. So the business benefits are there, They've been expressed in the same way all along with poor data quality, the operating KPIs, the challenges, and now we've layered on top decarbonization goals and high penetration DER goals in many parts of the world. That kind of changes the whole playing field. And I would just encourage everyone to take a fresh look at those KPIs and how are they changing and how does this fit into that?
Good, and I'm going to close it with one question. Each panelist can answer the same question, 15 seconds each. It's the title of the panel, right? Do you think that integrating design with construction and grid data can put a digital twin within reach? Dennis, we'll go to you.
Yeah, it certainly can, and it does. There are organizations that are doing it now. And I love the question about the benefits, because I think that's also a good way to end. What do I get out of it? Well, it changes everything. And you have to look, there are tactical things you can do that can do short-term justification. And there are long-term things you can do that can make transformative differences. And they are all there. And so I would encourage anyone to start small, focused, but have the big vision in mind.
How about you, Geoff?
I definitely think so. I think 3 years ago, I would have said, I see a real problem with the underground. We just do not have accurate underground data and we need it. But with the things that have happened in the last couple of years, I think we are now providing a foundation for a digital twin.
Yep, I agree as well, and I like the idea of starting small with the virtualizers and do incremental things, and then have other people in your organization support them and prop them up and see what you can do next. Randy, final thoughts, 10 seconds. Can it be done?
Yeah, absolutely. We have a technology innovation project focused on digital as-builting right now, and we are absolutely on board with figuring out how to make this workable and doable for the industry.
Excellent. Way to bring it home, guys. Thanks for the great panel. PJ, do you want to close us out here? Are you still there?
You got it. Thanks, Danny, and thanks, panel. Great presentation. Again, we would be remiss if we didn't thank Locust View for sponsoring and making today's event possible. For our audience, we hope you've enjoyed today's discussion. As you log off, please take a moment to complete our survey and give us your feedback so we can continue to provide you with quality content. Thank you for attending, and this does conclude today's presentation.
Thanks, folks.